For centuries, people have gazed at the stars and wondered, are we alone in the universe? The idea of extraterrestrial life has fascinated humanity throughout history. But only recently have scientists begun to seriously search for answers, using a variety of techniques and technologies to hunt for signs of life beyond Earth. The first step in the search for extraterrestrial life is defining what we mean by life. On Earth, life ranges from microscopic bacteria to blue whales and everything in between. But when scientists look for life elsewhere, they're often searching for even the most primitive forms, microbes, for example, since simple life is assumed to be much more common than intelligent civilizations. Despite decades of searching, we have found no definitive evidence of life beyond our planet. Yet recent discoveries have made the idea of life elsewhere seem increasingly plausible. Consider our own solar system. For a long time, Earth was thought to be the only place where life could exist. But as we've explored more worlds, we've uncovered unexpected possibilities. In the 1970s, spacecraft sent back images of Mars, showing vast deserts and dried-up riverbeds. Mars, scientists realized, had once been much wetter than it is today. More recently, robotic explorers like the Curiosity and Perseverance rovers have detected organic molecules, the building blocks of life, in the Martian soil and found signs that liquid water may sometimes appear near the surface. Elsewhere, moons like Europa and Enceladus, orbiting Jupiter and Saturn, are covered in ice but are thought to have vast oceans beneath their frozen surfaces. Geysers erupting from Enceladus have even been sampled by passing spacecraft, revealing water, organic molecules, and a chemical energy source, all ingredients for life as we know it. But the search doesn't stop with our solar system. In the last few decades, scientists have discovered thousands of exoplanets, planets orbiting other stars. Many of these worlds are surprisingly Earth-like. Falling within the so-called habitable zone, where temperatures are just right for liquid water to exist. Some of these planets are rocky, and some orbit stars much cooler than our Sun, challenging old assumptions about where life might thrive. While we haven't detected life on distant planets, scientists are developing creative ways to look for telltale signs. One method is to analyze the atmospheres of exoplanets as they pass in front of their stars. When a planet transits, a tiny fraction of starlight filters through its atmosphere, and sensitive instruments can detect the faint fingerprints of gases like oxygen or methane. On Earth, these gases are closely linked to biology. If we ever find a distant planet with a similar combination, especially if the chemical mix is out of equilibrium, it could be the strongest clue yet that something is alive there. Another strategy is the search for techno-signatures, evidence of advanced civilizations, such as radio signals, laser pulses, or even artificial chemicals in exoplanet atmospheres. The most famous example is the search for extraterrestrial intelligence, or SETI, which began in the 1960s. SETI scientists use powerful radio telescopes to scan the sky for unnatural signals, things that nature doesn't typically produce. So far, these searches have turned up only silence or occasional unexplained blips that later turn out to be interference from human technology. Still, with better telescopes and more sophisticated software, the search continues, now expanding to new frequencies and even to optical SETI. seeking flashes of light that could be transmitted across the stars. Closer to home, samples from meteorites have shown that many of the ingredients for life can form in space. Amino acids, the building blocks of proteins, have been found in meteorites that landed on Earth. Recent missions have even collected material from asteroids, bringing it back for laboratory analysis. These discoveries suggest that life's chemistry is not unique to Earth, but may be widespread throughout the cosmos. Despite all of these advances, the question remains open. Life could be common, but difficult to detect. It could be rare, or we might just be looking in the wrong way. The answer has huge implications. Finding even the simplest organism elsewhere would mean that life is not a miracle confined to this planet, but rather a normal part of the universe. On the other hand, evidence that Earth is alone could help explain the Fermi paradox. If the universe is so vast and old, why haven't we seen signs of anyone else? Until we have a definitive answer, scientists will continue to explore, analyze, and listen. By unlocking the secrets of life beyond Earth, we are not only reaching for the stars, but also learning more about ourselves and our place in the cosmos.